Hello guys, so in this video we're going to look into further properties of the roots of a quadratic equation. Right, so if alpha and beta are roots of a quadratic equation, now I have a set of examples here, set of quadratic equation, and we'll see what their roots are. Right, so what do you think? What would be the roots of this quadratic equation? Pause for a second and find the roots. Right, so if we find the roots, we can factorize this into x plus 2 into x plus 1. So our roots would be minus 1 and minus 2. You can see in this case both roots are negative. Both roots are negative. Right, and still and real, right? Distinct and real. Both roots are negative. So what about in this case, x squared minus x minus 2? What should be our roots? So in this case, our roots would be 2 and minus 1. Right? 2 and minus 1. X minus 2 into x plus 1. So x equal plus 2 and x equal minus 1. So what happens here? Our roots are, now when the quadratic equation is different, roots will also change, and you can see this is 2 and this is minus 1. Two different roots, one is positive, the other one is negative. So both in this case of opposite signs. One is positive, one is negative. What about in this case? In this case, when you solve this quadratic equation, you don't have to do anything. You just take minus 4 to the other side, then it will be x squared equals 4. When you take the square root, x would be minus 2 and plus 2. Minus 2 and plus 2. Right? So equal and opposite. So both would be in this case. Right? So roots are numerically equal because numerical this is 2, also this is 2, they are numerically equal, but opposite in sign. This is negative, this is positive. Right. Finally, we have this one. When you solve this quadratic equation, the roots you would get would be 1 and 2. Right? Both roots are positive. So these are the 4 cases that we will look into. Now we're going to check whether there is a relation. That means, can we predict what the nature would be like? Can we predict, just looking at this quadratic equation, can we predict whether the roots would be, both roots would be positive, or both would be negative, or one is positive, one is negative, or both roots are numerically equal and opposite in sign? So we're going to check what relationships bears with the coefficient of quadratic equation, so that we can determine whether our roots would be both negative, both positive, both of opposite signs, right, like this, and numerically equal but opposite sign. So if you look into this, you can see this relation is true for all types, right? This is in general. So both negative roots will be obtained if all of these terms are positive. So definitely this has to be plus 1, right? Definitely, it doesn't have to be. So suppose this is positive, right? Positive number, it doesn't matter. We will generalize this one in few minutes. You can see this is positive 1, or positive something is there. This is positive, this is positive. If both are positive, then both roots would be negative. Right? We will generalize this. Now in this case, this is negative and this is negative, but we can have a quadratic equation where if it is x squared plus x minus 2 equals 0, in this case our roots would be minus 2 and plus 1. Right? In this case, our roots would be minus 2 and plus 1. Still, you can say that both of opposite sign. This is 2 minus 1. This is minus 2 plus 1. What has changed? Right? So you can say the constant is negative. Constant is negative, but the coefficient of x is negative or positive. Either way, it doesn't matter. Either way, both roots would be opposite signs, right? So it doesn't matter what the sign here is. All that matters is the sign of this constant. You see, sign of this constant. So it doesn't matter in this case. If the constant is negative, then your roots would be of negative of opposite signs, right? If you look at this quadratic equation, still we have that, right? The constant is negative in this case, so both roots would be negative, that we know. Now you can see x term is missing. If x term is missing, definitely we know that the numerically they would be equal. And finally you can see constant is positive, but the coefficient of x is negative. If the coefficient of x is negative, then both roots will be positive. You don't have to memorize these, so we will generalize this idea in the next part based on a general quadratic equation ax squared plus bx plus c. So I just wanted you to know that these types of we can further classify roots based on the sign of the roots, right? Okay, I will generalize this idea in next part. Right, so the first case number 1 is when both roots are positive. What does that mean? If both roots are positive, alpha is positive and beta is positive. We have positive numbers, for example 2, 3, x equal 2, or x equal 3, x equal 10, or x equal 20, or x equal 1000, or x equal 10,000, right? Both roots are positive, right? So in that case, if you have two positive numbers, when you multiply it, what do you get? If you multiply two positive numbers, you get a positive value. So this is the product of the two roots. So alpha beta must be greater than 0, which means alpha beta must be greater than 0 implies C over A must be greater than 0. C over A must be positive. Okay. Next, alpha plus beta. Alpha plus beta must be positive. Why? We just add two positive numbers. In that case, alpha plus beta must be positive. In this case, minus b over a must be positive. Minus b over a must be positive. So we have a quotient. C over a is positive. What does that mean? C over a, when is a quotient positive? Quotient is positive when both numbers are of the same sign. Suppose negative 1 divided by negative 5, you get a positive 1 over 5. Positive 1 divided by, let me say. So negative 2 divided by negative 3 is 2 by 3. Plus 2 divided by plus 3 is also 2 by 3. You can see, if the sign of both of these numbers are the same, of same sign, then it would be positive. So we can argue here that A and C are of same sign. A and C are of same sign. It has to be same sign. If A is negative, then C has to be negative. If A is positive, then C has to be positive. So what about this? Negative B over A. Negative B over A. So when is this positive? This is positive when B is of the opposite sign of A. For example, this is negative. Suppose B is negative 3, then you have to select A to be of the opposite sign. So I can select A. This is negative, then a should be positive number. Let's say 2, then this is equal to negative negative, this is 3 by 2. Okay. Another example would be negative. If we choose b to be 3, if this is positive 3, then this has to be negative 2, then negative negative cancels out, 3 by 2. You can see b and a are of opposite sign, right? This we can argue b and a are of opposite signs, right? B and A are of opposite signs. Now you can see, for example, now if I want to get both roots to be, if I want to have both roots of my quadratic equation to be positive, then you have to select A and C of the same sign. A and C of the same sign. Then B should be opposite to A. So whatever the sign of A is, B should be opposite of that sign. For example, suppose I take 3x squared. You can see 3 is positive. So my constant should also be positive. Let's say this is 9. Right? This is 9. Or let's say just 1. Okay. Then our constant should be, our coefficient of x should be negative. Should be a negative number. Let's say negative 5x. Right? Equals. So if you solve this quadratic equation, you will get positive roots. Another case, if I just multiply this whole thing by negative sign, so this becomes 3x squared plus 5x minus 1 equals 0. Again, the same argument applies because the sign of A is also the sign of C and sign of B is opposite of the sign of A. Right? This thing satisfy our criteria. So this quadratic equation will also give you positive roots. Now keep this in mind. I couldn't get to this one at the beginning of this video, beginning of this part. Delta x. Now we are comparing the signs of the roots. So when we come to that point where we compare the signs of root, we assume our roots are real, right? Always. Otherwise we cannot do this. These are invalid if our discriminant is less than 0, because when the discriminant is less than 0, we said that our roots would be non-real or complex, right? You haven't learned about complex numbers just yet. So when you learn about complex numbers, you would know that there is no such thing as positive complex numbers or negative complex numbers. There is no such thing as that. So we cannot compare two complex numbers, but we can compare. We can assign a sign of like positive or negative to a real number. So we are only focusing on real roots here. So that's why discriminant has to be greater than or equal to 0. Always keep that in mind. So this condition must be met, right? After that we will look into these set of conditions, right? So this is when both roots are positive, right? Both roots are positive. So A and C are of the same sign, B and A are of opposite sign. So if this is met, if this criteria is met, then you can definitely say your roots would be, both roots would be positive. So let's look into the next case. Right. So when both roots are negative, what does that mean? Alpha is negative and beta is negative. Right? Alpha is negative, beta is negative. So these are the relationship we can obtain from this quadratic equation. The summation of the roots is minus b over a and the product is c over a. Now if both roots are negative, what would be their product? Suppose that our roots are negative 2 and negative 1. So negative 2 into negative 1 into negative 1, definitely plus 2. So the product, right? So if we have two roots, their product of the root must be definitely positive, right? Must be positive. So what does that mean? The product of the roots, even if they are both negative, must be positive. We learned that in grade 6. AB is positive, this implies again C over A is positive. What does that mean? That means A and C are of the same sign. A and C are of the same sign. If they are both of the same sign, then C over A will always be positive. So what about this? Addition of two negative numbers. That means negative 2 plus negative 1. If we add these two, what do you get? Negative, you don't try to multiply this. This is just negative 2, negative 1. It's the same thing. Negative 2, negative 1 means negative 3. Right? You can see if you add two negative numbers, you will definitely get a negative value. It will always be negative. So addition would be negative. This implies negative B over A is negative. Now if I multiply this by negative 1, you can see that this inequality will change. So that means B over A is positive. Right? Again we can see B over A is positive. So when is a quotient positive? That is when B and A, these two numbers are of the same sign. Right. So you can see A and C are of the same sign, A and B are of the same sign. What does that mean? That means all A, B and C are of the same signs. Therefore, A, B and C are of the same sign. They are all of the same sign. If they are all of the same sign, then we know that the roots would be both negative. Both roots would be negative. For example, all of the same sign means, just like I showed you earlier, x squared plus 3x plus 2. Positive, positive, positive. Can you see that? Right? Equals 0. Positive, positive, positive. Right? Another one, 15x squared plus 5x squared plus 10x plus 2 equals 0. Again positive. Right? So I have to make sure that the discriminant is also greater than 0. So that's why I take precautions when I'm writing this quadratic equation. But in general, you know that given this is true for the quadratic equation, you know definitely if we have the same signs, or if we have all the same signs like negative, 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 that means our roots would be negative. Both roots would be negative. Okay, let's get into the next case. Right, so in this case, case number 3 is when both roots are of opposite signs. Right? They are both opposite in signs. That means, for example, if one root is negative, the other one is positive 1. Negative, positive. Right? So suppose negative 10 or positive 10 is also possible, but we will take this as a special case. So 50 or 50. So this is what it means, are of opposite signs. So symbolically I have represented it as alpha is greater than 0. That means alpha is positive and beta is negative. Or alpha is negative or beta and beta is positive. Either case is fine. So we don't know what negative, which root is negative and which root is positive, but in general we can say either one of these is true. Right? So what happens if our roots are of opposite signs? What happens to our product? Suppose this is negative 2 and positive 1, these were the roots, then definitely this is negative 2. If the signs are opposite, we know that the product would be definitely negative. So alpha into beta will be negative. This will be negative. What does that mean? This implies C over A, which is equal to alpha beta, is negative. C over A is negative means A and C are of opposite signs. They are of opposite signs. Right. So what happens to alpha plus beta? Alpha plus beta will take the sign of the greater root numerically. Right? Numerically greater root. For example, if our roots would be negative 2 and negative 1, then the plus 1, the addition 2 plus 1 is negative 1. If our roots were positive 2 and negative 1, again our roots are of different signs. If you add these two, then you get plus 1. You can see the sign will change depending on the roots, the numerically, depending on which one is negative and which one is positive. So we don't really have to consider alpha plus beta. It will change depending on the roots, but definitely we know that if the roots are of opposite sign, definitely the product would be negative. So A and C are of opposite sign. So we don't really care about B in this case. So what does that mean? For example, A and C are of opposite sign. For example, A and C, 3x squared plus 10x minus 2 plus 10x minus 2 equals 3. So look at this quadratic equation. The sign of A is positive, the sign of C, that is a constant, is negative. Right? So B is positive in this case. Still, if you change this to minus 10x minus 2 equals 0, still it doesn't matter what the sign of B is. Both of these equations will have roots that are opposite to each other. Right? Both of these equations will have roots of opposite signs. So the roots will not be equal. Right? The roots are not equal. When you consider both these equations, they are not common to the equation, but the signs will be opposite in sign. Okay, so let's look into the last case. So finally, when both roots are opposite in sign and numerically equal, so what does that look like? If one root is alpha, then the other one is negative alpha. Right? If one is alpha, the other one is negative alpha. So I have written this as alpha equals minus beta. For example, if one root is negative 2, other root is positive 2. If one root is negative alpha, other root is positive alpha. So let me just rewrite it like this: alpha and negative alpha. Then this is clear, right? This is clear to you. So what happens in this case? Still, the roots of the signs of the roots are opposite to each other, which means their product would be negative, definitely. But what happens when you add them up? If you add these two, what do you get? If you sum these two, you get 0. If you sum these two, negative alpha plus alpha, again 0. Which means the summation would be 0. Summation would be 0. This one would be negative. Because in the previous case number 3, you can see the product is also negative in that case. So we have a way to distinguish between this case and the previous case, and the and the distinct can be made with this one when alpha plus beta equals 0. Right? So what does that mean? Still this has to be satisfied. Alpha beta would be negative. This implies C over A is negative. What does that mean? A and C are of opposite signs, and when you add the roots, when you add these two roots, you would definitely get 0. So alpha plus beta would be 0. That implies minus b over a equal to 0, and we know that a cannot be equal to 0. A is definitely non-zero, otherwise the quadratic equation will be reduced to a linear equation. So a cannot be 0, which means this implies b is 0. B is 0. Remember that quadratic equation, x squared minus 4 equals 0. The constant, the coefficient of x is not there. So now we can write this clearly. For this to be true, A and C are of opposite signs, opposite sign. So A and C are of opposite sign, meaning the roots would be of opposite sign definitely, but and B equals 0. So when B is equal to 0, then definitely you would get roots that are of opposite signs but equal numerically. Right? Examples would be x squared minus 9 equals 0. Example. You can see the coefficient is positive. Here this constant is negative. The sign is negative. And the b is missing. That means x term is missing in this case. So you would have equal numerically equal roots with opposite signs in this case. Right. So those are the things that we looked into in this video, and these things would be extra. We will do a couple of questions on these things. I mean, if you are good with the theory parts, like first 3 theory parts, then you are okay to try all the past paper questions. So this video and the previous video, this would come as extra. So but you have to know these things, the logic, how the logic was formed, because I mean there can be questions maybe in the future, or maybe it has been in the past, where they have asked you to derive the logic, right? Derive the logic for these cases. So it's better that you know how the logic works for, right? So thank you for watching. See you guys in the class.